Example 3 in 2.2 for Math 20-1 is actually very similar to example 1. They've just given us the information in a bit of a different way. So right away, I think it is important that if we want to know the exact values of sine theta, tan theta, and usually cos theta, I'm going to start this question just as a quick reminder that cos theta is x over r, sine theta is y over r, and tan theta is y over x. If you are struggling with that, I would highly recommend that you draw that out in the first quadrant. And then because your angle is right there, this is x, y, and r, and you can use SOHCAHTOA from there to generate those angles, or sorry, generate those formulas. Now, the reason why this is so important is they up here told me that cos theta is equal to -3/4. Now, r is never negative. R is the distance. It's defined as the radius of the terminal arm, so it's never negative. So that tells me that x is equal to -3 and r is equal to 4. So what I can do with that information is that when I draw it, I do want to identify that that's actually possible in 2 different quadrants. I could draw it like this with -3 for the x, 4 for the r, and I could also draw it, I'm going to draw it in red here, as this angle down there, because that would still have, if I made this 4, an r of if the r is 4, the x could still be -3. Now, there's a problem there because clearly it can't be both. And one of the things that you're going to struggle with is that if the question doesn't specifically tell you which quadrant it's in, you'd have to do a set of answers for quadrant 2 and a set of answers for quadrant 3. Fortunately, though, I'm going to label the quadrants in green here. This is quadrant 1, quadrant 2, quadrant 3, and then finally quadrant 4. The question tells us that we're in quadrant 3. So that means that this is invalid for this question, or at least not useful for this question. Now, because there's too much stuff going on in that diagram, I'm going to draw over here that in quadrant 3, this, and again, not to scale, it might not be close, it might be, this is theta. And I want to keep pushing that concept again and again and again, that the reference angle is useful. We're going to use that. But right now, this is the angle that's rotated from the initial arm to the terminal arm in quadrant 3. But in quadrant 3, the x is -3 and the r is 4. Now what we're going to do is we're going to go back and we're going to figure out what y is, because we need y for sine theta and we need y for tan theta. In order to calculate y, what I'm going to do is right off the bat, I want to make sure that you understand that without solving anything, I know that y must be less than 0. It can't be equal to 0. It's not on, that 180 degree mark. So if y is less than 0, it's really important that when we solve this, we think about, should y be positive or should y be negative? In this case, it should be negative. That's all that that's saying. Now, in this triangle, or in any triangle drawn in standard position, r squared is equal to x squared plus y squared. Now that means that r squared minus x squared is equal to y squared, or more useful to us, y is equal to the positive negative root of r squared minus x squared. And the reason why it's positive and negative, if you think about the diagram that we ignored over here, in quadrant 2 we would have a positive y, in quadrant 3 I would have a negative y. So even though it is a valid answer to say it's positive and negative, we identified that y had to be negative. So y is going to be equal to the negative square root of 4 squared minus -3 squared. With that bracket in place, this will work perfectly well. And I get that y is equal to the negative square root. I'll write that. It's 16 minus 9. So y is equal to the negative root of 7. Not to be confused with the square root of -7, which can't be done. That negative needs to be outside the radical. Well, now that I know what y is, and I know x, and I know r, right? We were given that in the question indirectly. I can say that the sine of theta, which is y over r, for this particular question, sine theta is going to be -√7 over 4. And we have to leave it like that. That's exact. Tan theta is equal to y over x. So for this particular angle, tan theta is -√7 over -3. What's the negative divided by negative? Well, it's positive, right? So the tan of theta should actually be written as √7 over 3. And I always like at this point, coming back to CAST. According to CAST, cos is positive in quadrant 4, all are positive in quadrant 1, sine is positive in quadrant 2, and only tan is positive in quadrant 2, or quadrant 3, sorry about that. Well, they gave us in the question that the cos of theta was -3 over 4. So cos is negative. We see that sine is negative, and we see that tan is positive. So our wonderful little cos, mnemonic is holding true, and we can tell which trig ratios are positive without actually doing any work whatsoever. Now, this is a harder question than example 1. You have to recognize that by giving us the value of cos theta, they've given us x and r, and then they narrowed down the quadrants so we could get a single set of answers. That's these two right here, sine theta and tan theta.